my Lord Mayor, Lady Mayoress, ladies and gentlemen, good evening. In this lecture, I shall talk about radioactive materials and radioactive waste. And in order to do that, I must first remind you that electricity makes a vital contribution to our lifestyle. In lighting, of course. On the farm, nowadays, with all modern farms, in the food industry, in providing pumps for our water supplies, in hospitals, in ways most of us don't even think about, electricity makes a vital contribution to our lifestyle. But electricity is taken for granted. And nevertheless, to guarantee the electricity supply, we must have transmission lines, we must have power stations, and in my opinion, we must have nuclear power. But Mr. Public says, I want all the electricity I need. I want the electricity to come on every time I press that switch. But I want that with no pylons, in my view, with no power stations near my home, and above all else, no nuclear waste in my backyard. The sense of this lecture is therefore that I am talking about nuclear waste and NIMBY. NIMBY, not in my backyard. It is this fear of nuclear waste and all things nuclear that has helped to push up the cost of nuclear power and delayed its commercial application in many countries. Therefore, today, I want to examine this fear of nuclear materials and the fear of radioactivity to see if it is rational. I therefore invite you in the audience, to do a thought experiment with me. Let us take the phrase literally. What is the actual risk of literally putting nuclear waste in your backyard? That's the first thing that we are going to do. Now, of course, you all know that what an American calls his backyard, an Englishman calls his garden. So let us first take an average English garden and ask the question, what's in it already? Clearly, it doesn't make any sense to examine the consequences of putting nuclear waste in it till we know what's there already. The answer is that your garden already contains a lot of radioactive waste, a very large amount. It's not mine, and it's not the nuclear industry's. It's God's. Because when God made the world, he made it very radioactive. And he left radioactivity lying about almost everywhere. Let's first look at that thought, and let's look at an average English garden. I'm going to take the size of my garden to be 1/10 of an acre. If your garden is bigger, then multiply everything I say by the size of your garden relative to this one. And I won't dig down very deep. I will just take the top meter of that garden. A hole you could dig in about 10 minutes. 15 minutes. And let us extract out of that top meter all the radioactive material that is there. In that top meter, you will discover there are 7,000 kilograms of potassium, some of which is potassium-40 and radioactive, nearly a kilogram of that. It has 6 kilograms of thorium, all of which is radioactive, and 2 kilograms of uranium, all of which is radioactive. Let me repeat to you, that radioactive waste has nothing to do with me or the nuclear industry. It's God's nuclear waste left over from when he made the world 5 billion years ago. Furthermore, it's nuclear waste that you own, because you own your garden. Let's have a look at what it looks like. Let's start by looking at the potassium. I can't bring you 7,000 kilograms of potassium because that would fill the hall. So I brought you a picture of it. And the pile of potassium sulfate fertilizer plus the bags behind the lady all add up to 7,000 kilograms of potassium. All of that is radioactive, and it's therefore material that you can just buy in the normal course of your daily shopping when you visit the garden shop or the supermarket. Let's start off by demonstrating to you that that is indeed radioactive. As you see, I have brought here a Geiger counter. This is the counter, this is the detector. And so, if I switch it on, you can now hear the counter counting the background radiation. That is the background radiation that's present in this room, simply because the materials of this room are radioactive, and we are being bombarded by cosmic rays from outer space. You can hear it. You can also see it on the dial. The dial is also linked to the counter, and you see we are registering about 2 counts per second. So that's the normal background radiation that you see. You can't escape it. It's there all the time. That's the normal background radiation. And here I have a bag of fertilizer, sulfate of potash. This is actually Arthur Bauer's variety. It makes no difference. It's all made by ICI, and they just they put it in a different bag. So there we are, sulfate of potash. Let's check if that's radioactive. Let's listen. And you watch the dial. You see we're up to about 12 counts per second. And you can hear it too. So there's no doubt that potassium sulfate is radioactive. But I also told you that we had some thorium. We had some thorium in your garden, 6 kilograms of thorium. One of the advantages of giving this lecture is you get to see what thorium looks like. It's something that doesn't, so far as I know, have any real use except in the gas industry. And you can tell already it's radioactive, just as I bring it nearer the counter. Shall we test it? You see, it's so radioactive, the counts have gone off the meter. So, that's in your garden. Repeat, it's got nothing whatever to do with me. It's not mine. It's not the nuclear industries. It's certainly got nothing to do with Sellafield. It's yours. And if you've got a bigger garden, you've got much more of it than this. The only difference between that and what you own is that this has been separated out. I told you also that you had uranium, 2 kilograms of uranium. You will see the same thing. It's radioactive. Let's detect it. Once again, you see it's sufficiently radioactive to send the counts over the dial. Again, that's nothing to do with me. That's God's nuclear waste that you own. It's in your garden because that's what nature or God decided should be there when the earth was made. Now, in fact, in your garden, the uranium is associated with radium and with radon. And both of those are actually more radioactive than the uranium metal by itself. Let me show you that. Let me switch on the counter again. And here I have a sample of uranium ore that has come from Canada. You see, it's a small sample, so there's not much uranium in it, but it's got within it all the radon and all the other radioactive materials that come with uranium naturally. All of that is in your garden. Let's detect how radioactive it is. You see, that is pound for pound more radioactive than the uranium metal which I showed you. Again, that's nothing to do with me, that's yours. In case you think there's something special about material that's come from Canada, this is a pebble that one of my colleagues found on a Cornish beach. Not the Sellafield beach, a Cornish beach. And it discovered it by accident, actually. You see, that itself is quite respectable, high degree of radioactivity. That is, in effect, it's dilute uranium ore. And the earth in your garden is, in effect, very dilute uranium ore. And all we have done is extract out the amount that you have got in your garden already. Now, all that radioactive material gives you and all of us a dose of radiation every minute of every hour of every day. And we know a great deal about it. We know that about 50% of that dose comes from radioactive gases in the air. That's the radon, primarily the radon that we were detecting when we looked at this piece of uranium ore. Some of it comes from outer space, from cosmic rays. Some of it comes as radiation from the ground or from buildings. Some of the radiation we get actually comes from ourselves, because we ourselves are radioactive. Our bodies are radioactive. They're bound to be, since all the food we eat is radioactive. And I thought that as the next demonstration, I would like to show you that the food that you eat is indeed radioactive. I've got here at the front of the bench 10 pots. And I've specially arranged them so that the counters there will measure the radioactivity. As soon as I switch them on, they'll count for 30 seconds and measure the radioactivity in the material in each pot. And the material in each pot is identified on the display board behind me. All we have done is we have taken tea bags. We have put them, arranged them in a little pot. We have put them in inside the lead box. And then we have taken a counter like that and put it down in the middle. I think all the materials, I think, will be self-evident to you. Tea you will certainly know about. I don't need to explain that to you. Low salt. Oh, that's a health food. Low salt is a health food sold by Sainsbury's as an alternative to taking sodium chloride. It is, of course, salt made with potassium instead of sodium. The Brazil nuts, they come from Brazil. You may like to know the instant coffee comes from Brazil also. Brazil is a very radioactive country, generally speaking. I don't expect you to eat the coal ash or the fertilizer. The North Wales lamb was taken at the height of the Chernobyl scare and has been freeze-dried. For God's sake, nobody eat it. That's by far the most dangerous material we've got. Nothing to do with the radioactivity, but because it's now been freeze-dried for about 3 or 4 years, and it's not actually edible. Now, when I press the button, the counters will count the radioactivity of these materials, and I'd invite you all to make a guess in advance. Which one's going to be the most radioactive? Make your guess, and we'll start the counts now. You see, the numbers start running up. You can probably detect already that fertilizer and low salt are both quite high. But we will see in the end of a 30-second run, that's as long as this counter takes. And then we should be able to read the numbers. There we are finished. And you'll see you won't be too surprised to see that the fertilizer is the highest. Low salt is the next highest. And the others all have various different levels. And all I'm doing is just, I don't want to make any particular sharp point about the levels that they are. I simply want to make the point that the food that you eat is radioactive, and the ground you walk on is radioactive, and there's no way you can escape it. And this has nothing whatever to do with the nuclear industry. This is all the natural radioactivity which God has put in your way. Now, if we wanted to be really serious about this subject, we would have to look at 2 factors. We would have to look at the actual radioactivity of the material, which defines the potential risk that that material has. And then we would have to look at the pathway by which the material could reach you. If something is very radioactive, but it can't reach you, then obviously it's not a risk. Whereas if it's slightly radioactive, but it reaches you easily, then that's something that you may have to take more seriously. And therefore, we have to take the potential risk and multiply it by a pathway probability in order to decide what is the actual risk to each one of us. Now, this concept of a potential risk and the pathway by which the material might reach mankind is actually quite a difficult concept to grasp quickly. In my opinion, it was best explained by a lady who happened to be a Catholic nun teaching in America. She actually worked in a Carmelite order, and she left that order by a special dispensation from Pope John. And although when she gave this lecture, she had ceased to be a nun. We all expected her speech to be phrased in careful, reserved terms. To be quite frank, we had expected it to be a little dull. Instead, she produced a startling analogy. She pointed out that a healthy young American man produced enough sperm to make pregnant every woman of childbearing age that was alive in the American hemisphere. And the potential risk from him was therefore very large. But how the young man would actually manage that task could not be imagined. And his pathway was therefore very difficult. And his chance of success was near impossible. And therefore the chance of that one man fathering 100 million children could safely be ignored. That is the best illustration that I have ever heard about how a potential risk has to be multiplied by a pathway probability in order to get at the final answer. There is, of course, quite a reasonable chance that that young man will father children, but not the 100 million that he is potentially capable of doing. Now, what is the end result of study in this subject? I've told you already, we know a great deal about it. Of every 1,000 people, we believe that one may die from natural radiation. Therefore, 249 will die from some other cause of cancer, chemicals, viruses, or from other causes unknown. And 750 people will die from something else. We are rather confident that everybody is going to die at some time. But you see, therefore, the risk from this radiation is modest, quite small. And we can conclude, therefore, that this natural radioactivity is not innocent, but the risk is small, very small, compared to the risks that you and I run in our everyday life. Perhaps that is why God could afford to be so careless with it, because it doesn't actually matter too much. It matters a bit, but not too much. And in evolution, it may well have had some advantages. Therefore, we can conclude that the risk from radioactivity in your garden is small, and you can enjoy your garden for a lifetime. In that lifetime, you must be supplied with electricity. Let's suppose it all comes from nuclear power. All of it comes from nuclear power. Not 20% as at present, but all of it comes from nuclear power. Then that nuclear power program will produce waste. The reactors produce some, the reprocessing plant produces some, and we can call it low-level waste, intermediate level waste, high-level waste, all different types of waste, including plutonium. And I'm not asking you to remember all the technical terms. Let's just take it that various types of nuclear waste comes out. Now, the public says, NIMBY, not in my backyard. And since we're doing a thought experiment, I'm replying, why not in your backyard? Let's take your fair share of nuclear waste and let's put it in your backyard. Then, if I do that, the amount of low-level waste that comes is your fair share from your lifetime is this box worth. That's the volume of the waste that you would get from low-level waste that would be your fair share. And inside here, this is your fair share of intermediate level waste. And if I look inside that, that is your fair share of high-level nuclear waste. And let's now imagine in your mind's eye that you have therefore got these three different types: low-level, intermediate, and high-level waste. And let's imagine that we put it in your garden. The low-level waste we'll just dig into the top meter. You can do that yourself. And the intermediate and high-level waste, let's put it 300 meters down, because that's what we will plan to do in real life. And then let's examine what's the risk of that compared to the risk of the natural radiation, the natural radioactivity, which you already have in your garden and which you already own. Well, to do that, we have to do two studies. We have to examine what is the consequence of the material that's up near the surface, and what is the consequence of the material that's deeper down. Roughly speaking, the material that is in the top meter will affect you because of the direct radiation or from breathing it. And the material that's in the deeper layers will affect you because it might get into the water stream. You might therefore drink it, or it might get into the food supply, and then you would eat it. So what we can now do is we can take this material and we can calculate the risk to you. Let's do the easy calculation. The easy calculation is, what is the potential risk to you? That's just comparing the radioactivity. That's very straightforward. Let's compare the radioactivity in your garden, if after we've put this material in it, compared to the radioactivity that was in your garden before we did it. When we do that, we conclude that the potential health risk from nuclear waste is small compared to the potential health risk from the natural radioactivity. But you may well say to me, well, that may be so, but you'd prefer not to add to your risk at all. You may say, well, you don't like this idea, and you would like to have your electricity from something else. You could, of course, nowadays elect to have it from gas. We can get the gas in from the North Sea, and sure enough, that'll last you about 15 years, and then it'll run out. So then you don't have a choice anymore. You're back to the old choice. Do you want nuclear power, or do you want coal? So let's examine the alternative. Suppose your lifetime supply of electricity comes from coal. Then we brought coal ash from deep under the ground up to the surface to make that electricity, and we've now got coal ash. That's a waste product. And so if we're doing our thought experiment, we now ought to consider burying coal ash in your garden. Let's bury coal ash in your backyard, and then let's ask you, which would you prefer to have? If you do the sum, a lifetime supply of electricity from coal produces 20 cubic meters of coal ash, which contains potassium, uranium, and thorium in the quantities which I've shown on the slide. Perhaps you can't envisage 20 cubic meters of coal ash, so I brought you a picture. That's your fair share of coal ash if all your electricity comes from coal. Let's imagine that we bury that coal ash in your garden. It's not difficult since we're only doing this in our thoughts, not in actual hard work. But let's do it. And then, if we do that, we will conclude that the potential health risk from the radioactivity in the coal ash is 1/10 of that that's in your garden already. And it's certainly larger than the potential risk from the nuclear waste. So, if you've got common sense, you ought to elect to have the nuclear waste rather than the coal ash. In both cases, we're talking about risks that are very tiny. We shouldn't really worry about either. But if you force us to compare it, we will conclude that the nuclear waste is the safer thing to have buried in your garden. But so far, we've only even done the easy comparison. We've only compared the potential risk, which is the easy sum for us to do. In addition to that, we must compare the pathway. What's the chance that that radioactivity can reach you? You remember our young man. So far, we've calculated potentially how many women he could make pregnant. We haven't figured out how many he can actually manage. That involves calculating the pathway. Well, when we do that, we come back to the comments that I mentioned to you briefly before. The coal ash, since it contains the same material, has the same factors in the pathway of reaching you, the human race. And of all the possibilities, the riskiest one is radon, because radon is a gas, and the gas can escape into the air, and you therefore breathe it into your lungs. If you can remember, and if you do remember, you deserve a prize. The risk from radon was fully half the risk from all natural radioactivity. And therefore, the pathway for that material is easy, relatively easy. And that, therefore, contributes appreciably to the final assessment of the risk. But here is an astonishing result. By sheer chance, all the materials that turn up in nuclear waste at the time that we would be burying it have very difficult pathways to reach you. None of them are gases, and therefore almost all of them find it difficult to get out of the ground and reach you with their radiation. And therefore, when we compare the actual risk, we find that the comparison is even more favorable than we have just assessed. So therefore, we conclude that on any rational assessment, the risk from nuclear waste and nuclear industry, at least so far as I've talked about it so far, is negligible. Why then are people so worried about it? Perhaps people are frightened because the nuclear business is relatively new, and perhaps they are simply unfamiliar with it. Perhaps they think it's something strange simply because they've never seen nuclear waste. Well, I don't know whether that's true or not. I don't know whether you are more convinced by logical argument or by practical demonstration. But since I want to convince you one way or the other, I thought I would bring along some actual nuclear waste and show it to you. I do that because people somehow think that there's something terrible about nuclear waste and you didn't dare get near it. Well, that's not the case, so let's demonstrate that. here is some low-level nuclear waste. It's real low, it's proper material. There's no pretending about it. That is low-level nuclear waste. It's mostly paper hankies, rubber gloves. I don't know which laboratory or establishment it's come from. Let's measure its radioactivity. We'll switch on the counter. That's the background counts. And here is the radioactivity of the low-level nuclear waste. I see I've forgotten to turn off my demonstration board, so I'll do that now. So this material is somewhat radioactive. It's more radioactive than fertilizer, but nothing up to the thorium or uranium level. Here we've got some intermediate level waste. We've got it here in a lead pot. It's a bit heavy. So here it is, sealed down with a bit of sellotape. That is the intermediate level waste. We'll measure that. You see, that's quite high, but you cannot tell from the apparatus I've got which is the more radioactive, the natural material or this. I think the most radioactive material per unit of volume is actually the uranium ore, which I showed you earlier. And finally, let me show you the high-level nuclear waste that is kept at Sellafield. This is actually a piece of high-level waste that's been made artificially to be just like high-level nuclear waste that is some hundreds of years old. See, it's, this is certainly the most radioactive material that we've got. I'm not actually proving anything to you by showing you that. Perhaps I'm proving to you that I'm not frightened of it. I am proving to you that it's not perhaps I'm proving to you that it's not all that scary. Certainly it's not something that you should think is an awesome, terrible thing you should do, that you can't dare even dream about. That's not, it's just simply not true. The risk from this material is overwhelmingly that we forget where it is and we sit on it. Then it would be risky. Now, let's see where we've got to. We've looked at natural radioactivity. That's God's nuclear waste. And we've looked at artificial radioactivity, which is the nuclear industry's waste. And we've compared the two. And we've decided that the risk from the natural radioactivity outweighs the risk from the nuclear industry by a large margin. But that, it doesn't matter anyway. It's modest. It's modest in the sense of its risks to society. Well, now let's look at the whole subject from a global philosophical point of view, because that might also help us to get these topics into perspective. When God made the earth, he was remarkably careless. First, he put all the radioactivity in the continental crust. That's where I am. He didn't put it in the center of the earth, and he didn't bury it under the ocean. He put it in primarily, overwhelmingly, in the continental crust. So he didn't try to keep natural radioactivity away from us. He almost deliberately put it in that part of the earth where human beings will be. Secondly, he arranged that the nastiest nuclear properties were associated with chemical forms that had the easiest pathway to get to us. For example, radon is a gas which can get into our lungs, and that gives us our biggest radiation risk. If that nuclear property had just been one step over in the chemical periodic table, it wouldn't have been a gas. It would have been a metal or an insulator. Certainly be a solid, and it would not then have been a gas, and it would not have reached us. And presumably he could have changed the laws if he wanted to, but he didn't think it was worthwhile. And so you must conclude that that was either perverse or careless. Of course, if you want to look more deeply into it, perhaps he did all that with a purpose in mind. There are good arguments, which may or may not be valid, that says that all this natural radioactivity has slowly contributed to the evolution of mankind. Third, may I point out to you that God, or if you like nature, I invite you to choose your own vocabulary. He gave us no senses with which to detect radiation. We have eyes to see, and ears to hear, and a nose to smell, and hands to feel, and a tongue to taste, but nothing to detect radiation. Why? Because it doesn't matter very much. We don't need to. Not at the levels that it is. If it did matter, then evolution would have made mankind develop with some other sense, perhaps a coil on the top of our head that detected radiation. But we can't actually do it. We can't do it because it doesn't matter very much. Remember, it's not innocent. I told you that perhaps 1 in 1,000 people die of it. But that's a very small risk to society compared to risks that we otherwise run. And therefore, in fact, we can conclude from that there actually are some good philosophical reasons to understand why radiation doesn't matter very much. And it's therefore very strange, at least it's very strange to me as scientist, that people are more worried about it when it comes from the nuclear industry than they are worried about more obvious hazards, which clearly affect them very much more. Now, if we want to examine the risks to society of either natural radiation or of artificial radiation, we need to know what are the average effects upon people, because that's what's needed to assess the effects upon society. And sometimes different experts argue about what are the effects of radiation on people's health. But that average effect, if you give a dose of radiation over a population, so you get an average effect, that must be simply proportional to the lifetime dose that you get naturally from the radiation that God has put here on the earth. And that conclusion must be valid whatever the model for the risks of radiation. Because as one man goes through his lifetime, he goes through all ages. So for one man, he's averaging the effects over his age. And for a population, you're averaging over people of all ages. And therefore, this conclusion is independent of any particular theory of radiation risk. That's a very reassuring result, because therefore we can simply note the risks, the radiation that comes from our nuclear industry, and we can compare it to the radiation that is available naturally. And we will always conclude, we always have concluded, that we're on the safe side. We're producing a risk that is much less than the natural radiation risk. Of course, if we assess what's happening in normal operations, the releases from the nuclear industry are totally negligible, and the risk is trivial. So we have to look at what is the risks from accidents or leaks, because our objective is to make sure that nothing gets out. It's only when something goes wrong that there's any chance of affecting the population. But even then, the risks are small. That's a very powerful result, because if you've got a situation where nature is setting you a natural standard, and which you know is all right for the general population, and you're able to stay inside it, then that's very reassuring. I don't know of any other industry where we can express the same confidence. Let's look at the worst accident we've ever had, the accident at Chernobyl. The population nearby received about 100 millisieverts. The natural lifetime dose in the same units is 200 units. The near effect from Chernobyl is about 50% of the natural effect. I'm not, of course, talking about the firemen who fought the fire during the actual accident. 28 of those men were severely burnt and died. I'm talking about the people in the surrounding countryside who suffered some degree of radiation exposure. And this slide tells you that it's about 50% of the natural radiation effect. It therefore won't be detectable. It's a very tiny effect compared to all the other things that have happened to the people. Those particular people were evacuated to Kiev. They've been looked after better since, and I think probably because they've had better food and better treatment since, they'll probably live longer than if the accident didn't happen. That, as you understand, is a personal guess. I couldn't prove it. I just think it is a plausible guess from visiting Chernobyl and talking to the people that were involved. So even if we have the worst imaginable accident that I don't think will ever happen again, we still are involved with negligible risks. And it's because of this general theorem about the effects of radiation on society being just a fraction of natural radiation risks, it's never seemed plausible to me that the leukemia clusters that have been talked about so much near Sellafield, it's never seemed plausible to me that they were caused by radiation in the environment. And I'm glad that the recent evidence seems to be confirming that is the case. It's not due to the leaks from Sellafield, because those produce effects which are tiny compared to natural phenomena. But in the last 2 weeks, you will have read a great deal about another idea that's just come up. It's been mentioned in the newspaper headlines, and didn't think it was fair to ignore it in my talk today. You'll remember the proposal, the new idea, is that because of radiation effects upon workers inside the Sellafield factory, that radiation on the man before a child is conceived can affect the child and give the child leukemia. The chance is small, but the proposal is that may be happening. That's a very specialized topic, but because it's so recent and it may be in your mind, I've thought it proper to spend a few minutes on it. To remind you again, it's the recent paper by Gardner and others who have proposed that there is an association between the radiation of the father before conception and leukemia in a child. Now, this is such a recent result that I think it would be improper for me as a scientist to either accept or reject this proposal. The work has been done very thoroughly and properly. It's not a silly scare story. It's a very responsible proposal. So I must take it very seriously, just like everyone else will. If the effect is proven, then of course it must be taking place naturally. But now, because it's very specialized, I can't tell you what's the ratio between this particular effect and the natural effect. But if this is happening to people who have accidents at Sellafield, then God is making it happen to everybody. We're not quite sure in what proportion, because we're not quite sure which dose level would matter and what ratios to find. And so that is something that we've got to examine. Gardner also finds a similar effect, namely a similar association between the father and the son. If the father works in the chemical industry or the steel industry or the farming industry, he puts that in his own paper. Now, that has nothing whatever to do with radiation, and therefore partially our conclusion must be that work is bad for you and for your children. I've actually always known that. Now, to help decide this, we should now look urgently at the children of radiologists. Radiologists get quite a dose of radiation, and they also have children. So if the hypothesis is right, we ought to see this effect very strongly with radiologists, and we ought to look at that now quite rapidly. So far as I know, no effect has been noticed up to today. Furthermore, if the phenomenon exists, there ought to be a correlation between leukemia incidence and the natural radiation background. And none has actually been seen. There may be, but there are so many correction factors to be applied that perhaps we ought to do those sums again. Therefore, I have some reservations about the results. If you ask me to guess, I would expect there to be something in it, but I suspect it will turn out to be less dramatic than perhaps at the moment it seems. But of course, that's all about talking about society and the risks to people as in a very generalized sense. That's not what we ought to be doing. We ought to be talking about individuals, because it's individuals that matter. We are not just talking about numbers. We're talking about individual people who are worried. And BNFL should therefore look urgently at the individual cases to decide whether the common link is radiation or some other industrial activity. It could easily be something else, or it could be the radiation. We don't yet know. I think this they must do as a caring employer, and to be fair, perhaps they should have done it earlier. But we can conclude then that with the possible exception of this Gardner hypothesis at Sellafield, the radiation effects from the nuclear industry can be expressed as a small fraction of God-given radiation effects, even when we have accidents and leaks. But in routine operation, the effect is trivial compared to nature's pre-existing levels. Now, I would like to stress to you that that cannot be said for any other pollution problem that is in the top priority of urgency for mankind at this point in time. If you look at CFC and the ozone hole that it produces over the Antarctic and the Arctic, we mankind are producing CFCs at an infinite rate and an infinite amount compared to that which God has already produced. No wonder we're disturbing the balance of nature. We're way off beam compared to what God has already provided. When we produce sulfur dioxide and cause acid rain, we, mankind, are producing in the northern hemisphere about 10 times more than that which God produces naturally and puts in the atmosphere in the northern hemisphere. And when we produce carbon dioxide and are producing therefore the greenhouse effect, we are producing an appreciable percentage and a steadily increasing percentage of the carbon dioxide that God has put in the atmosphere at this point in time and throughout the time when the human race has existed. So for all those other cases, the pollution is larger or a more important fraction of what is produced naturally. Now, there is one exception to that. There is one exception to that, and that may well be plutonium. Is plutonium special? It's frequently said that plutonium does not exist in nature. It's the most toxic material known, and 1 kilogram could kill off all mankind. Now, all three statements are wrong. Since uranium exists in the ground, plutonium exists in the ground, admittedly in a small amount. It's certainly not the most toxic material we've known. And 1 kilogram couldn't kill off all mankind. In fact, there are a number of Americans who accidentally drank some plutonium, and so far as I know, most of them are still alive. They're now old, but still alive. So, I don't have time to go through detailed arguments, but I can assure you that although plutonium is produced at a higher rate and in higher quantities than God has already provided for us, when you examine that too, you discover, in my opinion, validly, that's not a risk to mankind. But I told you before that perhaps you're the kind of people, some of you may be the people who like arguments, and some of you who like to see things, and therefore just in the hope that that will help to capture your confidence, I thought I would also tonight show you some plutonium. So far as I know, that's the first time it's been done in a public lecture, in the United Kingdom. It has been, this plutonium has been mounted in Perspex. It's a relatively small amount, and I'm not proving to you anything at all. It's certainly radioactive. The radioactivity, of course, is greatly lessened by the fact that it's been mounted in the Perspex. That's to make sure that we don't lose any of it. And I haven't proved anything to you at all by showing it to you, except that I'm not frightened of it. And that means either that there's nothing to be frightened of, or I'm a very foolish man. And I hope you'll decide that I know what I'm doing. And I hope that I have therefore reassured you about risks from the nuclear industry. Thank you very much.